The first one was about self-replicating robots. Robots that can reproduce, create copies of themselves, make babies like humans do, robots. The second story was about a tech firm which is offering money to people to have their faces imprinted on robots to create what they call robots with human faces. Now, I don't want to jump to conclusions or question the intention of the scientists involved. But it's hard to not ask this question. Have these people never read science fiction? They're creating robots that can multiply and machines that will look like us. What could possibly go wrong?
Life finds a way.
We'll begin with the reproductive robots. They're being nurtured in the United States. Scientists have created robots that can produce an offspring. They're calling them XENOBOTS. This is what they look like. These tiny organisms that you see, these spherical clumps, they're XENOBOTS. And they're not made of metal or plastic. They've been created from biological tissues, which essentially makes them living robots. Robots that can move on their own, heal on their own, and now, of course, reproduce on their own.
These are the world's first living robots, and they are, in fact, I would argue, something new under the sun. They tap into, help us understand ancient forces as old as life itself. These are hybrids, biological machines that represent an amazing synthesis between computer design, human insight, laboratory expertise, artificial intelligence, and the innate capabilities and mechanisms of cells. Reported last year, XENOBOTS are computer designed. They're hand-built biological machines. They're assembled from frog cells that have been shown to be able to move on their own, find targets, retain information. And now, as you may know, in a new study published this week in PNAS, the Proceedings of the National Academy of Sciences, the science team, the folks gathered here today, report that XENOBOTS are able to self-replicate. It's a form of biological reproduction never seen before.
How exactly were they created? In order to design these XENOBOTS, scientists first created random 3D designs on a supercomputer, like the one that you see. Simulated blocks of skin and heart cells that can move on their own. These blocks or configurations were then assigned tasks through an algorithm. What kind of tasks? Like walking in a certain direction, basic things. The most promising configurations here, the ones that perform the tasks well, were then taken to a lab to be injected with life. Life taken from African clawed frogs. These toads that you see, they're the source of life in XENOBOTS. This species is found in sub-Saharan Africa. It can regenerate its skin when wounded. So this is what scientists did. Take out skin and heart cells from the embryos of these organisms and then inject them into 3D blocks through tweezers and electric tools. Once injected, these blocks were kept in dishes of water to keep the frog cells alive. Not only are these creatures alive and kicking, they're reproducing. They're creating copies of themselves, just like molecules do. So what are they doing? First, they release loose cells, then they smush them into clusters, swash them with water, and if the cluster is large enough, within a few days it takes a new life. It evolves into a child XENOBOT. Does sound like a fun experiment, but the question is, what's the point of it? What are these XENOBOTs for? What are they going to do? Here's a human question for these living robots. What is their purpose?
Well, the XENOBOTs tend to raise more questions than they answer. So I'm not sure exactly what the implications are at this point. If we zoom in on a XENOBOT to the level of a single cell, it's not new. It's a part of a frog. But then we zoom back out And a xenobot doesn't look like or replicate like anything we've ever seen before in nature. They look more like robots building other robots, as you mentioned, more like robots